Oh, no, it's histogram time here, people. All right, so histogram. What is a histogram? Well, as we can see here and read here as well, a histogram, all right, is a graph of a frequency distribution in which rectangles with bases on the horizontal axis are given. Are you kidding me? Come on now. All right, so pretty much it's a bar graph. It's a bar graph. But instead of it having like a category with words, it's got an interval of numbers. Okay, so the best thing to do is to just kind of take a peek and see what we got going on here. Okay, here we go. All right, so what it'll do is it'll break things into groups. So how many people are ordering extra smalls? All right, so that means that they had a measurement from 510, but it has to be less than 530. So because it's less than 530, it means not including 530. All right. So what we would do is we'd go through and we would go ahead and we would tally all of them up. All right. And then we'd come up with the frequency for it. So for example, let me get it so it's spaced here nicely. Should be easier than this, shouldn't it? Yes. Okay, so like for example, 513. 513 would fit there, so it would get a tally mark, so VI, all right? 525 would also fit in between there, so it'd get a tally mark. There we go. 531 would fit in there, so that would get a tally mark. 533, you see where I'm going with this. Whoa, look at that. All right, yeah, we fast forward there. Okay, so again, you get the idea. The other thing is they were broken up into groups. They were in order, so we could kind of count them up there for a bit. But again, the idea is we could use a tally chart to figure out the frequencies so that we can organize some of the information that's here. So if someone had a head circumference of 570, what size would they need? So 570. Oh, wait, no. Yes, it would have to be the large there because, again, this medium is if you have less than 570. What hat size does the data center around? So again, center around, well, yeah, it's around the size medium there. And again, the center is where most of the action is happening at. So let's see. The following histogram shows the first two intervals from the frequency table. And you can see from 510 up through the 530, it's a 2, yes. The 530, but less than 550, we're up at an 8, and yes, we're at an 8. So complete the rest of the table there. So the whole idea now is, as we go through it, we've got 15,942. So 15, we're going to be in the middle. That's there. All right. And then we had 9 of them for the next one. So again, we're between the 8 and the 10. And then we had 4 of them, and then we had 2 of them. So certainly, if we want to go ahead and do the shading with it, we could. All right, just to kind of be consistent with it. Certainly not a requirement, just as long as the graph is easy to read, and that's what's important about there. So, based on the histogram, describe the center of the head circumferences. So we would say the center would be somewhere from 550 millimeters to being less than 570 millimeters. And it says, how would you change the histogram if you added head circumferences of 551 and 569? Well, if we added in the 551, we would be in here. We would notice that we'd be up to a 16. 569, if we notice that, that's going to be, where's that at? Yeah. Oh, hey, it would be in there. So it would simply increase the center of our distribution there. So I don't know, how would the histogram change there? And it's not going to change much because the center's not going to change as much. So the center. So how would it change? Well, like I said, I don't think you're going to see much of a change. Poor question here, I think here. I guess you could say the center interval, all right, would be 2 higher, two higher than before, 2 more than before. Not thrilled with that question there. All right, so let's go here. So shape. All right, so shape. Let's get into there. So shape of a histogram is used to describe. All right, there are different ways to describe important features of the distribution that's here. So this is what we call symmetric. Something is symmetric is if we have the same on both sides. So you notice that if we would cut it right down the middle, we'd have the exact same thing to the left as we do to the right. Here we've got a graph that's skewed, so it's more to the right. More of the action is happening to the right. Here we are skewed because more of the action is happening to the left. This is actually skewed, all right, left. Even though the graph is leaning to the right, the information over here is what's causing the graph to be skewed. Now, kind of a funny word, but skewed kind of means what's shifting it to be off. And then this would actually be skewed right, because again, the information that's throwing it off is off to the right-hand side there. So let's see what we got. A group of students want to find out how long a certain brand of AA batteries lasted. The histogram below shows the data distribution for how long in hours that some AA batteries lasted. Would you describe the distribution as symmetric or skewed? Okay, and pretty much looks like we got the same thing going to both sides there. Again, pretty much if we did this, we would be something like, we kind of look at the general shape here, just going right off the edges. Yeah, we look pretty symmetric there, all right? We'll abbreviate there, because again, it looks pretty balanced. Again, not going to be perfectly balanced, but it looks pretty balanced there. Here, if we kind of look at there, we're here, we're here, we're here, we're here. All right. So then, yes. What do you think? This is going to has a skewed shape. Well, we think it there because more, all right, information is to a side. So again, when more information is to one side, whether it's the left-hand side, whether it's the right-hand side, that's what's going to let us know that it is going to be skewed. So here they go. We got the tally chart. We got the frequency chart where they want you to make a histogram. So what we want to make sure that what we're doing here is noticing we've got labels. Oh my. They've already given us the intervals that are down there as well. So they certainly have done a lot for us. But 80 less than 90, there's only one that's there. So yeah, 80 less than 90. So that would be a 1 that we're after. I'm gonna then we got a 4.75. So we're up to 4. All right. All right. We're up to 7, which I need to. There we go. And then we're up to 5. All right. 4.75. 7.31. All right. 7. All right, and then a 3. Oh, I got a little sketchy there, huh? All right, there we go. So again, not the perfection, but again, we can read the graph pretty clearly. Describe the shape. Well, if we're kind of looking at it there, I know it dips down there, but overall the shape does this. Yeah, it's looking pretty symmetrical. And again, if we went down the center, it looks like it's about the same to either side. That's the key thing that we're after. What does the shape tell you about the length of movies? Well, it does tell us that most movies are, and again, what you say, I would take between, again, we look at most of them there, between 100 and being less than 30 minutes there. Actually, I'm going to use mine in there. So if you want to say something in the middle, like the average is about 115, I think we could take that as well too. But again, as long as we're talking about most of the movies are happening here, I'm going to buy that from you guys. All right. That's lesson 5. So again, main things here. Did you notice the vocabulary that's there? Symmetric and being skewed. Did you also notice the makings of a histogram? A lot like a bar graph. Wouldn't you say so? Whoa, no, I think so. We got bars. It's a bar graph that's there. All right. But that's your histograms.